Okay, I believe that we are live now. And so I'd like to do this review. It'll take a few minutes for everyone to join. I'm going to go ahead and take the event link right now, and I'm going to post it in Schoology so that everyone can know that it's there and can join. So I'm going to go ahead and do that right now while there's not much to see. I will say while I'm starting to get this up that the main things I'm going to cover right now are going to be the essential skills. I'm going to cover those thoroughly. I'm going to cover writing reactions, like translating reactions, predicting products, translating, balancing, also predicting products, and then spend a little bit of time on that. Will the reaction happen, yes or no, based on if it's a single or double replacement, actively serious liability rules, and end with any questions you have on the lab. So I'm sure that will be of interest to people. All right, so I'm embedding the link right now. And I'm going to send it to all the classes. I cannot do more than one thing at a time, unfortunately, so it's just gonna, you'll have to bear with me as I'm doing this. 86543 all the classes. Okay. Hangout is going on now. Okay. So I'm posting that in all the Schoologies, so hopefully everyone will be able to see it. I'm also going to try to periodically, I'm going to monitor my emails as best I can to see if there's students that are there trying to say, hey, I'm trying to get into the email. It looks like everyone's doing, or looks like nobody has contacted me about that. So people, I believe, are starting to get on there. So maybe there's some questions. No questions yet? That's okay. Also, we're in the process of getting the kids down to bed, so the door's open. Just in case something happens, I might have to step away for a moment to make sure that everything's taken care of. I apologize beforehand, but hopefully it won't be an issue. All right, so I'm going to go ahead and start into the essential skills. What I'm going to do is, now that I'm thinking about this some more, I believe that I have a worksheet maybe you guys haven't done before. And let me open that up. Reactions, worksheets. Let's take a look. Oops. All right, I think this will work all right. Okay. Where are we again? Sorry. Okay, so now I'm going to share my screen, and we'll take a look at this. Maybe I'll make it a little bit bigger so that you can see. Oops, I don't like when that happens. It takes a moment. Hold on. That's not clearing up at all. That's not helpful. Oh, there we go. Oh, and I just messed it up. Oh, there we go. Okay. I'm hoping you guys can see that all right. Okay. So let's just start with the first balancing equations. And I'm going to pick number 1. And I'm going to share the screen, or I'm going to share my Bamboo tablet. And I'm going to rewrite that problem. Okay. Where am I? Something's going on my screen. Okay, so it's, I seem to be having more difficulties. Wow, this is just not very helpful. Okay, S, I, and then we have Cl4. Okay, and we don't have to worry about the subscripts that are the numbers or the letters after it, the L, the S, the AQ. Remember, those are liquid, solid, aqueous. Don't have to worry about those so much. Plus H2O, and that's going to yield SiO2 plus HCl. Okay. So let's change the color while we're doing this. Makes it a little bit easier. You know, if you remember, I like to go left to right. So one silicon, 4 chlorines. Only one chlorine here, so I have to put a 4 out front. Okay. Then I have 2 hydrogens, and that's 4 hydrogens now. So I'm going to put a 2 over here, and now I've got 2 oxygens and 2 oxygens. Hey, that works out pretty well. 1 silicon, 4 chlorines, 4 chlorines, 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. Okay? Now, those are, I believe that one's an easy one. Let's do one that has polyatomic ions. So we have, oops, let me change the color on that. Back to that blue color. And we have an Hg. That did not come out so well. I'm having difficulty this evening with just about everything. Hg. Oops, my mouse is, this is so much fun. Okay. Oh, this is in parentheses, OH2. And that's plus H3PO4 goes to, and unfortunately because it's so long, I need to come down here. That's okay. Hg3, so G, Hg3, PO4, 2 plus H2O. And this has a couple concepts baked right into it, which is why I like it. I want you to notice something. Here's an H2O, and then here's an H and an OH separately. So that's going to be one of those situations we know that we can cross out the H2O and make it easier. We're going to have H, OH. So we'll have 2 different things we're balancing. So now we can balance it. We've got an Hg and an Hg3. So I've got to get to 3 Hgs out in front here. Okay, those are balanced. I have 3 times 2 makes 6 OHs, and only have 1 OH here, so I can put a 6 out in front of that. I have 3 H's right here, and I have 6 H's there. That's going to be a problem. So I'm going to put a 2 out in front of this. That gives me 6 H's and 6 H's. And that gives me 2 of the PO4s and 2 of the PO4s. Just to double check, 3 HGs, 3 HGs, 6 OHs, 6 OHs, 6 H's, 6 H's, 2 PO4s, 2 PO4s. So we're good. So those are that encompasses most everything you need to know about that. So hopefully the balancing equations won't seem too hard. Let's see if we have any questions now. We have, can we review, oh good, Laura, can we review the solubility rules for double replacement reactions? Sure, absolutely. Okay, so what I'm gonna do is, I guess, I'm gonna open up the notes on this. Let me open those up. Okay. And then we can take a look at them together. I'm going to make the screen for the notes a little bit bigger so you can see it when I switch to that screen. Okay, let's share the notes now. Okay, so now we're sharing the notes. You guys can see. So, and we're going to go down to what you're asking about. Now, you can recognize a double replacement reaction. That's the first thing, right? Can you recognize a double replacement reaction? And a double replacement reaction has 2 compounds in the beginning and 2 compounds at the end. And the main thing you need to be able to recognize is that those 2 compounds are different. They're different because the 2 cations probably switched places. Okay, the 2 cations switched places. You'll notice there's an A right here with the X, and now the A is with the Y. The B was with the Y, now the B is with the X. Okay, so that's the first thing. You can recognize a double replacement reaction. I like to say it just goes on and on for days. Like here you can see compound plus compound yields compound plus compound. I mean, there's just so many. That's a double replacement. That's when you know that you're using the solubility rules. Now, it starts on page 4 with the activity series, but we want page 5, right? So the solubility rules are only for double replacement reactions. And when you look at this, everything in this column, and I'm going to highlight it because, oops, that's not what I wanted. Sorry. There we go. Everything right here. All these yellow ones right here, these are all rules. Okay, those are all rules. Those are the ones that say, hey, if it's an alkali metal, it's soluble. If it's a hydroxide, it's insoluble. Okay? Then all of these ones in this column are actually the exceptions. Okay, so I'm going to make those, what color? I guess it doesn't really matter. Or actually, it is going to matter. I'm going to make it matter. We'll make them this light blue. Okay, so all these light blue ones are all the exceptions. Okay, so hydroxides are insoluble except when they're with alkali metals and ammonium. Okay, so that's how you're reading this. But here's the thing that's really going to matter to you guys, because the question is going to be, does the reaction happen or not? And all they want to know is, does it make a solid? Okay, so now what I'm going to do is I'm going to highlight this whole section, and I'm going to, where is it? I thought there was a fill-in section. I guess there isn't. I thought there was going to be a really cool thing I could do, but it's not so cool anymore. I'll just make this all bold and make it 18 font. No, that was a bad idea. We'll just make it all bold for right now. All these things right here, these are all solids. So solids equal yes. That means a reaction is happening. Okay, so this is all solids, and solids mean yes. Okay, so that's this area right here. Oh, there we go. Origin shading. Shading. Nice. Okay, so we'll make that all green. Okay, solids equal yes. All right, that's insoluble. That's where the insoluble is. Insoluble means solid. All right, then we come down here. These are also insolubles. Okay. We'll do the same thing here. Okay, these are solids. These are a yes. Solids equal yes. Okay, So that's these two areas. Now, these are the rules, these are exceptions, but the exceptions make it a solid. That means it's a yes, okay? Then this whole area is a no. Oops, that's not what I wanted. Origin shading. And we're gonna make this red. Hopefully it doesn't totally, okay, good. This is all red. This is a no, okay? So we'll say, no solid equals no. No solid. If it's soluble, it dissolves in water. This is a no, just like this area right here. These exceptions make them a no. Okay? If you put something together and you get a solid out of it, that's a yes. Okay, so if two things react and you end up getting a solid out of it, that's a yes. So let's write some reactions. Let me do some examples. Here we go. I'm gonna do the bamboo paper. All right. Solubility. Okay. And we said this way, solubility, that's a double replacement. Solids equal yes. Okay, let's make this black. All right, so now if we had some compounds. So, and remember, we're only looking at products. I should write that up here. Okay, so now I'm gonna write an equation and we'll see if we can figure it out. All right, so I have a NaCl plus an AgNO3, okay? And since this part's not a predicting price, we're just gonna figure it out. So then we do double replacement, so the Ag and the Na are gonna switch spots, and we're gonna get an AgCl plus NaNO3. All right. Now, the reason I know it's this is because I remember that the Na is going to be an Na plus, the Cl is going to be a Cl1 minus, the Ag happens to be a 1 plus because it's always 1 plus, and the NO3, that's a polyatomic ion, is a 1 minus, so it's all 1 1. So now what we're really looking at is we're trying to figure out, is this or this a yes or no? And I look at AgCl, that's the first one. So now I'm going to go back to the solubility rules. So let's take a look at them real quick. Okay, we're looking for AgCl. So I look at the rules. The rules are where you look first. I look at Ag. Do I see Ag in these rules right here? No, I don't see that. I look down here. Is Ag in the rules down here? No. And I take it ion by ion, each step, okay? I don't see silver anywhere in there. Okay, so let's go to the next one, chloride. I look through chloride. Is this chloride? No, no, no. Oh, there it is, right there, okay? Chloride means it's soluble, so that would be a no. Then I need to look at the exceptions, and the very first exception is silver, okay? So silver is the exception to chloride, the rule that is chloride. So silver chloride is insoluble. It makes a solid, so that means it's a yes. All I have to do is have one of the products be a yes, and the whole thing is a yes, okay? So I go back here, and I look at this, and I don't even have to look at AgNO3. This right here is a yes. So that means the whole reaction is a yes, okay? It just so happens that if you were to look back at the rules, sodium is an alkali metal, is always a no. Nitrates also happen to be a no. So this whole thing would be a no. I mean, so this compound would be a no. But this is a yes, so yes. You say yes to the reaction. Yes, a reaction happens. Okay? Solid AgCl is formed. All right? So let's do another one. Take this back to black ink. And let's say that I'm going to do, what's a good one? Let's do, oh, I already did NA. I don't want to do that one again. Let's try to shake it up. Okay. Let's do NH4 with a CO3 carbonate. So it's NH4 CO3 plus, let's do K2SO4. Okay, and when those combine, you're going to come up with NH4 2SO4 plus K2 CO3. All right, that's a pretty hefty looking one. So try to remember that. Let's go look at the solubility rules. And so our first one, if you can remember, was NH4CO3. So I look up here and do I find NH4? And I look down, there it is, NH4 plus. It's a no. And is there an exception to it? There is no exception to it. It's a no, okay? And even if you look at the CO3 2 minus, you'd say, oh, look, here's CO3 2 minus. It's a yes, except for that the exception is ammonium as well as alkali metals. But so that means that one's out, okay? Oh, I'm sorry, we're looking at products. NH4 and SO4 2 minus. So SO4 is also a no, and NH4 we've already said is a no. Now, K2 and CO3. The K up here is an alkali metal. It is a no. And then you look and say, oh, but CO3. CO3 is a yes. CO3 2 minus is a yes. But alkali metals are the exception, and K or potassium is an alkali metal, so that one's a no. So there was a chance it was going to be it, but we've got no all the way across. So I'm going to show that one more time. Where's mine? There it is. And so we get, I mean, if we were to break it down by ion, that's a no, that's a no, that's a no. This would be yes, except for this is the exception. So that one's a no. That one's a no. The whole reaction is no. No solid is formed. Okay? So you have to go back to the solubility, which we give you on the test. We give you the solubility rules. You go back on the test, take each of just the products, each ion in the product separately, and see if it is, and if it matches up with an exception or whatever it is, so you can identify which one causes it to be a reaction, a yes to the reaction, which one causes it to happen. Okay, so that is the solubility rules. Hopefully I covered that for you, Laura, and anyone else that was watching. So I'm gonna be done with that question. Please put some other questions in there though, because anybody who wants to go through this and look for things to study is only gonna have one question so far in the first 26 minutes. All right, so we covered essential skill number 1, which is balancing. And so essential skill number 2, essential skill number 2 is reaction types. And there's 5 of them. You should remember them pretty well. There's synthesis. There is decomposition. There is single replacement. There is double replacement. And there is combustion. Okay? Now, there's the basic things that you add together, like the basic formula, right? Synthesis is A plus B gives you AB. Decomposition is AB together. Then you go into 2 things, A plus B. Single replacement A plus BX yields AX. Oof. Oi, it does not look good at all. AX plus B. And double replacement, AX plus BY gives you AY plus BX. And then combustion is some hydrocarbon plus oxygen yields CO2 plus water. Okay? And the things that you need to look for in this, there are, in synthesis, two things become one. In decomposition, one thing becomes two. Okay? And they could be elements or they could be compounds. We'll do an example for each one. In single replacement, one thing replaces another thing. Okay? That's one thing replaces another thing, kicks it out. Kicks it out, okay, and takes its place. In double replacement, they switch. The A and B just switched. They're with different X's and Y's. And then in combustion, this is always the same. O2, CO2 plus H2O. If you see that, that's combustion for sure, okay? So let me give you some examples of some other, good, oh, what did I do with it? Oh, now I probably put it away somewhere. I was looking for that. I was looking for some equations that were already up, but I'm gonna make up my own. It will be just fine. Let's do synthesis. Now for synthesis, okay, you could have H2 plus O2 yields H2O. And if you balanced it, I think you'd have a 2 and a 2. You could have something like Na plus CO2. Is this right? Gives you, this doesn't feel right. That's okay. Na2CO3. Okay, I don't know how to balance that, but you can see that there's two things, even though this is a molecule, two things becoming one thing. Okay, now decomposition. Decomposition. You can have NH3 breaking down into N2 plus H2, two things, or one thing becoming two things. You could also have H, we're gonna, oops. You could also have H ClO4 breaking down into H2 plus ClO4, let's just say. So that happened. Okay, so here's a compound, and that's okay. All right. So now we can have, and remember, it's just one thing becoming two things. Single replacement. And we've been doing a ton of these. I don't know how to make these any more clear sometimes. You could have Na plus CuSO4. That should, CuSO4 should look familiar. In fact, I'm just gonna be a funny guy and say this is Fe plus CuSO4 gives you Fe2SO4 plus Cu. Hey, look, there's a single replacement, right? This is replacing this. Like must replace like. I don't know. So maybe I should write that down too. Cations replace cations. And anions replace anions. Okay, like replaces like. Okay, so this could also apply to, not, and hopefully you won't get confused by this, but if you have a Cl2 plus KBr, goes to, well, what's going to replace what? Well, the Cl is a halogen. It's to the right of the zigzag line. Br is a halogen. It's to the right of the zigzag line. So what's going to happen is the Cl is going to replace the Br and kick it out. In fact, we're going to kick it all the way out to over here. So you end up with Br2. And when it does that, then you get the K matching up with the Cl then. Okay, and the Br2 and the Cl2, those have to be diatomic because they're part of Brinkelhoff. All right, okay, let's do double replacement really quick. This one we've talked about a couple times already. That's all right. So let's do an HCl plus NaOH yields NaCl plus H2O. Okay, and the H and the Na switch spots. And you know that H2O, if you have an H2O on one side and you have an OH and an H on the other, you can of course make this into HOH. It makes it a little bit more obvious that that's a double replacement, but don't forget, just remember and recognize that. And so I would say that just switch, just say cation switch places. Okay, that's an easy way to do that one. All right, and finally, combustion. Okay, and for that one, you could say CH4 plus O2 yields CO2 plus H2O. And it can be any combination like C3H8 plus, what's the rest of it going to be? Same thing every time. O2 plus CO2 plus H2O. This time I'm going to make it C4. Let's do C6H12O6 plus, look, it's the same thing. H plus O2 gives you CO2 plus H2O. So you can see right here, it's the same every single time. This is combustion. Doesn't seem no matter what with these hydrocarbons over here. It's plus O2 yields CO2 plus H2O over and over and over again. So please don't get tricked by that. All right. So that's essential skill number 2. And finally, well, let me double check. Are there any more questions? Oh, there were questions. Oh my goodness, lots of questions. Hello, Diana. Okay. Apparently I'm going to need to get the study guide. Let's see if I can grab that really quick. There it is. Oh wait, that's not it. I apologize. This is going to take me just a second to find this and bring it up. At least I hope this is the case, that this is what you guys were looking for. All right. Okay, so I'm gonna start at the bottom and work our way up. Can you please go over number 21A on the study guide? Sure, 21A. Okay, so you are balancing that reaction. So let's go ahead and write that on the bamboo paper. Or wait, let me show you the study guide first. Okay, so here's 21A. All right, so we're gonna do that one. So let's share the bamboo paper. Okay. Let's change it to a different color. Okay, and so the equation was Na plus Na NO3 yields Na2O plus N2. This is funky looking. I don't think I've ever seen this one. I didn't make the study guide. That's a wild one. All right, well, let's see how it works out. Okay, I've got one Na and two NAs, but I actually have two NAs because there's two NAs and there's two NAs. Okay. There is one nitrogen here and there's two nitrogens there. So, and of course you're doing this in pencil. So I put a 2 here. So now I've got two N's and two N's, and I have 6 oxygens and only one oxygen here. This is going to be a little unusual. So what if I put a 6 right here? Okay, 6 oxygens, 6 oxygens. I now have 2 nitrogens and 2 nitrogens. And since this is 12 sodiums, 12 NAs, that's 2. That means we have 10 NAs left. So if I put a 5 here, and that's it. Oh, no, that's not right. No. I thought there were 2 NAs there. Let me try that again. 12, and that's 2. I have to have 10. Oh, so I have to put a 10 right here. So I have 10 NAs, 2 plus 10 plus 2 is 12. 6 times 2 is 12. 2 N's, 2 N's, 6 oxygens, 6 oxygens. It's balanced. So 10, 2, 6, and 1. And that's how you balance number 21A. All right, kind of a funky one. All right, next question you had up there was, do we have to memorize the acids and their formulas for the test? Yes, I've said that a couple times. That was like the first thing I said when we first studied this. Yes, you have to memorize the acids and their formulas. That was an easy one. Next one, I was not at school today. Did we go over what's going to be on the written portion of the test at all? Not really. I think I've told you guys before you should know, let's see. I think what we said is we're going to have the translating, right? So that part of like taking the words and putting them into a formula. And then you're going to have to predict products. Just like that. So that's that worksheet, right? That's side 1. That's side 2. And then you're going to have to balance. Side 1 and 2. And probably have to do I don't know, you might have to say what the reaction type is. And that's essential skill number 2. And then you have to say if it happens yes or no. And that's the predicting product side 2. And then you'll probably have to tie it into lab. And that's obviously the lab. So that's all that I said for that. There, I just gave you more than like 4 of the classes. All right, good deal. Okay. And last question, will we have review questions from previous units on the test? And the answer for that one is yes, absolutely. Every single test has had review questions from previous units on it. We build all the way up to a final exam that has questions from every single unit in the whole year on it. Like chemistry is one of those very rare subjects where every single unit builds on the unit before it. Like we're always tying things in together. It would be horrible of us to not have stuff tie in. So yes, there'll be review questions. Okay, now, Sabrina has a question. Could we please do number 20 on the study guide? It's kind of long. So let's take a look at that. So number 20 on the study guide, where is it? There we go. Oh, the whole thing. Yeah, I can do that. Okay. So let's share. I'm going to do a bamboo. Oh, you know what? Might be easier. I can just type right on that. That might be easier for this one. Yeah. Okay. So this reaction is endothermic. So what you would do is, being the responsible students you are, you would say heat. Because you would want it to be there to remind you that heat is a reactant. Okay, So now we're doing the teeter-totter thing. Let's see if I have a ruler anywhere around here. That would be really cool. I don't seem to have a ruler. How odd. There used to be a ruler in the drawers. I'm going to guess that one of my children has it. He's running amok. All right, we'll just use a pencil. That'll work. Okay. So number 1, increase the amount of NH2. NH2 is a reactant. Okay, NH2 is a reactant. We're going to increase the amount of that. So, all right. Here's the pencil. All right, and reactants to products. I hope that's what's showing on your screen. Reactants to products. I can't tell if it's going backwards or not. Reactants to products. If you increase the reactants, okay, it's going to shift to the right. It's going to produce more products. If you add to one side of the teeter-totter, the other side has to be added to get it to level out. Okay, so add reactants, shifts to products. Let's go and write that down. So increase the amount of NH2. It will go forward or right or favor reactants. Okay. All right. Okay. So now we decrease the amount of N2. Decrease the amount of N2. And what will that look like? Now we've got our, it's in the reaction side, if we decrease the amount of N2, all right, there's your teeter-totter. You took somebody off this side, which side's gonna go? Well, it's gonna have to go reverse because you're gonna have to get, you always have to put somebody on the top part of the teeter-totter. Well, if the top part's on the reactant side, on the left, that's where you need to, that's where it's gonna shift to get back to equilibrium level, equilibrium, okay? So let's go ahead and put that in. This is taking a long time with going back and forth between this. So after this, I'm not going to switch back and forth to my screen. Left, reverse, favor, oops, this is favor reactants, haha. Is that right? This is, if it goes to the right, it favors products, my apologies. Some of you are probably yelling at your screen, you did it wrong. All right, this is now NH3. If you increase the amount of NH3, it's gonna shift. If you increase NH3, it's gonna shift left. So now you're gonna have this again. You're gonna go left, reverse, favor reactants. If you add heat, remember this is all about, you balance it back and forth, okay? You balance it back and forth. And if you add heat, it's on the left-hand side. So it's gonna favor, it's gonna go forward, forward, right, favor products, okay? Right. If you decrease the amount of NH3, okay, it lifts up the product side. All right, so then you're going to go forward, right, favor products. Okay, just think about that teeter-totter. If you increase the pressure, all right, now we need to go back. I need to go back to the screen. I want you to look at these coefficients, okay? This is a 3. We're gonna make the coefficients yellow. That's a 3. We're gonna make this a 1, so because that's 1 yellow, and this is a 2. Okay, which means we have 2 on the right and 4 on the left. 2 on the right, 4 on the left. Okay, so all right. So if we increase pressure, it decreases volume. Increased pressure decreases volume. When you put pressure on something, you push it down, and we're talking about gases only, so it squishes it down and we're losing that space. So it wants fewer moles or fewer molecules of gas, which means, if you remember, the right side only had 2 and the left side had 4, so it wants to go to the right side. It favors the products. Forward, right, products. That's what happens when you, in this case, when you increase pressure, it decreases volume, fewer molecules, which they're around. Okay, so let's switch back. All right. So this is another forward, right, favor products to get smaller. Remove heat. Now this is just the opposite of add heat. If you're removing heat from an endothermic reaction, if you remove heat from an endothermic reaction, that's going to pull the reactant side up. So then it's going to go left, reverse, favor reactants. It's going to do the exact opposite of what we did when we added heat. And decrease pressure, now we do the exact opposite, increase pressure. Decrease pressure, you back off. It gives you lots of space. And it now wants to be on this side because this side has more molecules. So you're going to go left, reverse, favor reactants. Okay? So hopefully that answers those questions about number 20. But yeah, that's, and that's essential skill number 3, really. We just did essential skill number 3, that whole problem. There's a ton of questions on equilibrium in the test. So we kind of killed 2 birds with 1 stone there which I really like. All right, so we've done that question, number 20. And if any of these questions, if I don't answer the question adequately, you need to re-ask the question or something, and make something different about your question so that I understand that I need to phrase something differently. So, all right, actually, Wilhelm has a question. Can you go back to when you were talking about the solubility rules? Sorry, I don't know how to ask a question, but I was confused how you got K when it was a no and the element was a yes in one of your examples. Okay. So let's go back to the solubility. Let me share that bamboo paper. Okay. All right. And, oh, that, not far enough. Okay. Oh, right here. Okay, I'm assuming it's this one right here. Your question, let me review this question again. Can you go back to when you're, okay, confused how you got K when it was a no and the element was a yes in one of your examples. Okay, so here's the thing. If you look at the solubility rules and you looked up carbonate, carbonate is in the yes column. It's a rule that says when you have carbonates, it's going to form a solid, so it's going to be a yes. However, K is the exception to carbonates. K is an alkali metal. So you have a rule that says yes, but when you have an exception, that changes it. That's why the whole thing is no. Alkali metals are the exceptions to all things. Okay, so whatever rules you have that say that a rule like hydroxides, carbonates, phosphates, sulfides, those are all yeses, except when there's an alkali metal, then it's a no. So let me just share the picture of the notes. Rapido. Okay, so you can see that alkali metals are the exception to everything. They make everything soluble. They make everything a no whenever you have an alkali metal. And it just so happens that alkali metals are their own rule. But those are the exceptions. Okay, that's why that one's a no. Even though it was paired with a yes, because it's the exception, alkali metals are always going to be no. All right? So hopefully that answers that question. All right, done with that question. Another question from Ashley Wilhelm. How do you know whether it's the reactant or product side pressure is being increased or decreased? Okay, good question. Do you remember that I threw away the ruler? I said, don't do the ruler when you are doing pressure because it's not one side or the other that's having its pressure increased. It's the whole reaction, okay? So let me do the bamboo paper. Okay, so if we have, actually let's make this black. Let's say we have a big, okay, a big circular container. And the reaction is N2 plus H2 in equilibrium with NH3. And we have the coefficients as a 2, 3, and a 1, which means that overall it's a 4 on the left side and it's a 2 on the right side. So what's happening though in this reaction is that you have N2s floating around and you have H2s floating around, and you have NH3s floating around. Okay, so let's say this is a big container, and I have, look at all of these H2s and N2s I have. I only have, for the sake of picture, NH3, 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 NH3. We only have 4 NH3s, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of the N2s and H2s. Now, when we have this reaction, what's happening is, let's say that pressure gets applied and it starts making this smaller. Okay, so what happens is it's actually going to get rid of this. Okay, we're going to get rid of 1, 2, 3 H2s, and we're going to get rid of 1 N2. Okay, and then you're left with 2 NH3s. Okay, so what happened is, in this situation, it got smaller. Okay, and so we lost 4 molecules. We gained 2 molecules. So there's a net loss of 2. So we subtracted 2 from the overall. There was pressure. There's less space. I didn't do a very good job with this, but you know, we can fit. If we have to get to a smaller one, and we get something like this, you know, all these ones fit in. There's not as much space. So the reaction is going to favor the product side because it means that they'll have fewer molecules if they go that direction, and it'll be easier to fit in that space, and it will maintain the same pressure. Okay, if we did another one, let's see if I have this. So I've got to get rid of 3 more H2s. 1, 2, 3, and 1 more N2. Okay. And so then I put, oops, well, that's okay, NH3, NH3. I've gotten rid of 4 and I subtracted 2 more. Okay, and now they can fit into the space. And because they're going to consider all these molecules the same size. Technically they're not, but there's gas law stuff that we're going to talk about later. They're just counting the number of molecules. And the number of molecules means that you need less space if you keep pushing on it. Okay, so it's not a sign. Don't do the teeter-totter rule with this. It is just, is it smaller or is it larger? And if it's smaller, then you want fewer molecules. It's going to favor the side that's going to produce fewer molecules. If you have something larger, you have less pressure, it's going to favor the side that can give you more molecules. If we went the other direction, then we'd have to erase the NH3s and make more H2s and N2s so that the overall would be larger. Okay? All right. Last thing I want to talk about, and we kind of already talked a little bit about it, but I need to get off in like 2 minutes because I have an AP Chem Google Hangout that I'm going to do because they also have a test tomorrow. So exciting. Is the lab. Okay. And so I'm going to go ahead and do this. All right. So you had a test tube, and let's just quick talk about it. And I'm not going to give you all the details on it. Okay. You had a blue test tube. Is there any other? Is there a lighter blue? There it is. This is a good blue. This is like the same color. Okay. And so these are the things you need to think about. We had a brown. Oh, what a bummer. We'll make it orange. And we will make it, ooh, let's make it really thick. Is there a way to make it really even thicker? No, not really. That's okay. So there's a nail in here, okay? And then there was like brown stuff coming off and filling the bottom, okay? So this is what I would say. right? Okay, so what's the question? What was the question from the lab? Okay, which hypothesis did you pick? Okay, so is iron more reactive than copper? Okay, and to do this, what's the name of the lab? Activity series. All right, activity series. And things you need to think about is, what was your data? What happened in the lab? What happened? What, when you did some massing, you did some stuff like that. What happened? That's going to be really important. And then finally, I would say, what happened in the blue tube? Okay. What is the brown stuff and where did it come from? What is the brown solid and where did it come from? See, what is the brown solid? Where did it come from? And how did you know? Horrible handwriting. My apologies. Okay. Oh my goodness. Diana, I see you have a question. 21E. You need to come and see me tomorrow morning. I don't have time. I have to get off right now. Okay. So I hope that this was helpful. And of course, come and see me if you have any more questions. And I will see you all in the next couple of days for the test. So good luck with that. All right. Adios.